Today we're going to discuss the back questions of chapter 3, laws of motion. Sorry. So, first question is which of the following will always be in the direction of net external force acting on the body? So, according to Newton's second law, force is equal to ma. That is, acceleration is directly proportional to the force and it will act in the same direction. Therefore, we can say that the answer to this question is option C, acceleration. Okay, this is because according to Newton's law, second law, F is equal to ma. Next question is, when a constant net external force acts on an object, which of the following may not change? Justify your answer with an example. So let us take an example that is in a circular motion with constant speed. The direction of velocity will change, but the speed will be constant. That is, this change in speed is change in direction is due to acceleration. So we can say that the option is speed. That is, um, in a circular motion. So when something is moving in a circular motion, it will be having constant speed. But the direction of velocity will be changing. And this change in direction is due to acceleration. Okay. Next question is, a 0.5 kg ball is dropped from such a height that it takes 4 seconds to reach the ground. Calculate the change in momentum. Okay, so let us do it. So U is equal to 0. Okay. And there is an equation of motion. Equation of motion. Equation of motion is V is equal to U plus GT. So here G is given. G is 9.8 meter per second square, and time is also given 4 seconds. Okay, now substituting the values to the equation, V is equal to 0 plus 9.8 into 4. And when you solve this, you will get a value of 39.2 meter per second. Now we need to find the change in momentum. So change in momentum is equal to mv minus mu. Now substituting the values, 0.5 into 39.2 minus 0. And the value will be 19.6. Okay. Next question is, in which case will there be larger change in momentum of a 2 kilo object when 10 N force uh, act on it for 1 second, and when 10 N force act on it for 1 minute? Calculate the change in momentum in each case. Okay. So fourth question. So force is given as 10 Newton. Then time is given, that is 1 second. So change in momentum is change in momentum is equal to F F into T. So that is 10 into 1, which is equal to 10 meter per second. Okay. Now, sub question 2. F is equal to 10. S is equal to 1. So from the equation, so there is an equation like V square is equal to U square plus 2AS. So from this equation, we can say A is equal to F by M. That is F is 10 and M is 2, which is equal to 5 meter per second square. Now substituting the values, that is V square is equal to 0 plus 2 into 5 into 1. So the answer is 10. It is V square. So V will be root of 10. So root of 10 is V is equal to root of 10, that is approximate value is 3.16 meter per second. Now we need to find the change in momentum. So change in momentum is mv minus mu, which is equal to 2 into 3.16 2 into 3.16, which is equal to okay. So we can say that the larger change in momentum occurs in option A. That is sub question A. Okay. Next question is, a ball of mass 0.2 kilogram falls through air with an acceleration of 6 meter per second. Calculate the air drag on the ball. So net force is equal to mg minus drag force. Okay. And using the equation F is equal to MA, we can say that 0.2 into 6 is equal to 0.2 into 9.8 minus abstract. That is, instead of net force, we are putting MA value. Okay, that is 0.2 into 6. 0.2 into 6 is 1.2, which is equal to 1.96 minus. Now from this, we can find the value of, okay, so value will be 6 Newton. Next question is, a load of mass 20 kilogram is lifted with the help of a rope at a constant acceleration. The load covers a height of 5 meters in 2 seconds. Calculate the tension in the rope. In a rocket, M changes with time. Write down the mathematical form of Newton's law in the case and interpret it physically. So a load of mass 20 kilogram is lifted 5 meters in 2 seconds. We need to calculate the tension. So for this, we will be using the equation S is equal to UT plus half AT square. So initial velocity is U, which is equal to 0. Now substituting the values. We know S is equal to, that is speed is 5. 5 is equal to U into T. U is 0. So 0 into T is 0. Okay, so we'll just write half into, we don't know the value of A. So we'll write half A into 2 square. Okay, that is you can cancel the 1 by 2 A4. That is 2 and 4 you can cancel. So it will become 2A. So 5 is equal to 2A. From this, you can find the value of A. A is 5 by 2, which is 2.5 meter per second square. Now we need to calculate the tension. Tension is T, which is equal to mg plus ma. That is 20 into 9.8 plus 20 into 2.5, which is equal to 20 into 9.8 is 196 plus 50. And the answer is okay. Next question is a ball of mass 0.1 kilogram moving at 10 meter per second is deflected by a wall at the same speed in the direction shown. What is the magnitude of the change in the momentum of the ball? A ball of mass 0.1 kilogram is moving at a 10 meter per second speed, and it is deflected by a wall at the same speed. We need to calculate the momentum. So momentum is delta P equal to MVF minus MVI. F and I is subscript, okay? So now you can take M outside, that is VF minus VI. So now you can substitute the value 0.1 into 10 minus of 10 and when you solve the equation you'll get a value of 2 meter per second. Next question. Find the average recoil force on a machine gun that is firing 150 bullets per minute, each with a speed of 900 meter per second. Mass of each bullet is 12 gram. So average recoil force on a machine gun firing 150 bullets per minute, that is momentum of one bullet. MV will be equal to MV will be equal to 0.012 into 900. That is around 10.8. Now, number of bullets per second. Number of bullets per second, that is equal to 150 by 60, which is equal to 2.5. So recoil force will be into 10.8. Momentum of one bullet into number of bullets per second, that is 27. Okay. Next question is, explain why when catching a fast moving ball, the hands are drawn back while the ball is being brought to rest. So by drawing hands back, the time take to stop the ball increases. This is according to impulse momentum equation. So basically, while you're throwing a ball, your hand or you're drawing back because the time of the impact increases. So according to force into F into T, according to F into T is equal to, so increasing the time will reduces the force and this make the catch less painful. And that is the reason why we draw hand back while we are catching a ball. Because when the time increases, it will reduces the force and it will make it less painful while you're catching the ball. And this is according to the principle F delta P is equal to F into T. Next question is, a constant force of magnitude 20 Newton acts on a body of mass 2 kg, initially at rest for 2 seconds. What will be the velocity of the body after 1 second from start, 3 seconds from start? So F is equal to ma. We know that equation. That is second law of Newton. So 20 is equal to 2a. From this, you can find the value of a, that is 10. Now, after 1 second, v is equal to 0 plus 10 into 1. That is 10 meter per second. Now, after 3 seconds, v is equal to, again, 0 plus 10 into 3, which is equal to 30 meter per second. Okay. 11th question is, how does a force acting on a block in the direction shown here keep the block from sliding down the vertical wall? So the vertical compound F sine 30 degree, it will balance the block's weight. So the vertical compound F sine 30 degree will balance the block's weight, and the horizontal compound F cos 30 will provide a normal force, and this will result in increasing the friction. So basically, the applied force is having a vertical compound, that is F sine 30, which balances the weight of the block and prevent it from sliding down. And the horizontal compound F cos 30 will provide the normal force. And this will result in increasing friction to counteract this downward motion. Okay. 12th question is, a 1.2 kg block is resting on a horizontal surface. Coefficient of static friction between the block and surface is 0.5. What will be the magnitude and direction of the force of friction on the block when the magnitude of external force acting on the block in the horizontal direction is? Okay. So, normal force, that is mg, is equal to 1.2 into 9.8, which is equal to 11.76 Newton. So that is the normal force. Now maximum static friction is equal to 0.5 into 11.76. That is equal to 5.88 Newton. Now external force is equal to 0. So friction will be equal to 0. And when external force is equal to 4.9, friction will be equal to 4.9 Newton. When external force is equal to 9.8, friction will be equal to 5.88. This is because it is reaching the maximum limit, because we already found the maximum static friction. So it will only reach 5.88. 13th question is, for a block on a surface, the maximum force of static friction is 10. What will be the force of friction on the block when a 5 Newton external force is applied to it parallel to the surface on which is resting? So the applied force is 5 Newton and it is less than maximum static friction, that is 10 Newton. So the frictional force will be 5 Newton. Next, what minimum force F is required to keep a 5 kg block at rest on inclined plane of inclination 30 degree? Coefficient of static friction between the block and inclined plane is 0.25. So here, weight component down the plane. Weight down the plane is equal to mg, that is f sine 30. Mg sine 30, which is equal to 5 into 9.8 into 0.5. Answer is 5 Newton. Now frictional force is equal to mu Sn. Okay, mu Sn, that is 0.25 into mg cos 30, which is equal to 0.25 into 5 into 9.8 into 0.866, which is equal to 10.6 Newton. Now minimum force required is equal to 24.5 minus 10.6, which is equal to 13.9 Newton. 15th question is, two block P and Q of masses M1 2 kg, M2 3 kg respectively are placed in contact with each other on horizontal frictional surface. Some external force F is equal to 10 Newton is applied to the block. Find the following. So there are two blocks, P and Q. So question A. A is equal to F by total mass, which is equal to 10 by 5. That is 2. Now force by P on Q. So force by P on Q is equal to M2A. So M2 is 3 into 2, which is equal to 6. Two blocks P and Q of masses M1 equal to 2 kg and M2 equal to 4 kg are connected to a third block. For what maximum value of M will the system be in equilibrium? So maximum value of M for equilibrium will be frictional force on P. Okay. So frictional force on P is equal to 0.5 into mg. M1g, that is 0.5 into 2 into 9.8, which is equal to 9.8 Newton. Likewise, frictional force on Q. Frictional force on Q is equal to 0.5 into M2G, which is equal to same 0.5 into 4 into 9.8. This is equal to 19.6 Newton. Now total friction. Total friction is equal to 9.8 plus 19.6, which is equal to 29.4 Newton. So there is a downward force due to mass. So the downward force due to mass is M is equal to mg. So for an equilibrium, mg should be less than or equal to 29.4. So mg should be less than or equal to 29.4. So when you divide this 29.4 by 9.8, mg 29.4 divided by 9.8, you'll get a value of 3 kg. So m should be less than or equal to 3 kg. 17th question is, explain the role of friction in the case of bicycle brakes. What will happen if a few drops of oil are put on the rim? So when brakes are applied, friction between the brake pads and the rim will slow down the wheel. That is what happens. So if you're adding oil, it will reduce the friction. It will make it hard to stop the bicycle, increase the stopping distance. Now the last question is, 2 kg block is pushed up an inclined plane of inclination, imparting its speed. How much distance will the block travel before coming to rest? Coefficient of kinetic friction between the block and the inclined plane. Okay. So the distance traveled before coming to rest on an incline, initial velocity is equal to 20 meter per second. Acceleration due to gravity along the incline, that is g sine 37 is equal to 10 into 0.6, which is equal to 6 meter per second. Now force due to friction, that is mu kn. Mu kn is equal to 0.5 into mg cos 37, which is equal to 0.5 into 2 into 10 into 0.8 equal to 8 Newton. Now total acceleration, that is A is equal to 6 plus 4, which is equal to 10 meter per second square. This is because both gravity and friction act in the same direction. So using the equation, V square is equal to U square minus 2AS. V square is equal to 0. U square is 20. U is 20. So 20 square is 400 minus 2 into 10 into S. So from this, we need to find the value of S. S is equal to 400 divided by 20. It is 20. So with that, we finish the back questions. I hope it's clear. So thank you for joining. If you have any doubts, you can ask in the next session.